coronal mass ejections, sunspots, coronal holes, solar flares, cosmic ray flux, and lots more is what we cover on the Smash News Network. Least busted name in news. We've got some spectacular coronal mass ejections propagating as we stream the video. Thanks for tuning in to the most comprehensive space weather and detailed solar imagery you'll find in the known universe. This is a 24-hour video from SDO. And the real story is filaments. So we are expecting a minor uptick here in the general solar parameters that we typically cover. Let's take a quick trip around the horn and see what's going on, as you may see some activity happening. So we've got some activity setting in the western limb. There is a limited possibility of flares from the southwestern portion, this active region setting down here. We've got a bunch of South Pole-oriented coronal holes facing the Earth. And we are seeing high-speed winds from those. We've also got a coronal hole closing down here and some what we would call limb darkening, as we watched another CME happening yesterday, propagating out of there, out of the southwestern limb. You can see that happening. Some plasma making it back down toward the chromosphere, other plasma making its way into the greater solar system. We've also got a series of sunspot groups there in the southeastern limb. One of those is fairly large and quite magnetically complex. Quick reminder that sunspots are less likely to produce large flares while they're in the Earth-facing portion of the solar disk, referred to by some as the Earth-facing quiet. Of course, there is a valid physics explanation for that, and it's not magic or anything outside the realm of actual science. Perhaps we'll have to make a cosmology video about it, as that's the reason we cover heliophysics in the first place, to advance both cosmology and human technology. Here's a great view of a rising sunspot in the northeast there, and that sunspot group is large. It will be solely responsible for an uptick in the X-ray flux and the radio flux in the coming day or two. Just keep in mind the magnetic environment can change suddenly with basically no warning. That is, sunspots can suddenly evaporate or suddenly grow. There you can see one of those coronal mass ejections in the upper left. There's also one happening in the upper right. So again, it's a story of filaments. And you can see massive filaments here all over the earthly facing portion of the solar disk. Filaments, filaments, filaments. We'll cover those in more detail. Also another CME erupting over here. That is I believe that one was named the Steve Bannon filament by one of our viewers. And if you want to name filaments after living people, head to Twitter, follow the hashtag #NameThatFilament. Let's take a look at a full disk view here for sunspots. And we've got a new group that formed up here in the northwest also. So we'll have at least 2 new named sunspot groups today. This one is currently highly likely to produce large solar flares, and this one, as it sets on the western limb, will become more and more likely to produce large flares. These SDO browse data movies are yesterday plus today. That is April 25th and April 26th so far. A little bit of inconsistent umbral migration happening down here. Let's go back to the intensity gram. We do have this South Pole umbra here speeding away from the North Pole umbra. So that's a feature. Let's take a brief moment to see what's going on planet Earth, as we've got some interesting seamount volcanoes. Yeah, some undersea volcano activity happening. We'll get to it here in a minute. First, Suwanosejima is producing a 5,000-foot ash plume as it explodes. Flight level 050 over the Ryukyu Islands. Mount Ibu exploding on Halmahera, Indonesia. Flight level 070. 7,000-foot ash plume over Halmahera. And there you go. There's the breakdown of Ahi, part of the U.S. Mariana Islands. And it's been discoloring ocean water since the 18th of November 2022. The possibility of a large eruption there is pretty serious, as it could produce, well, it could put lots of water into the stratosphere, for example, if it erupted in a spectacular fashion. The current alert level is, quote, unassigned. Okay. Popocatépetl continues to explode in central Mexico, produce a 20,000-foot ash plume. It's a flight level 200. Flight level 220 over Ecuador from Sangay. Flight level 250 over Sabancaya in Peru. It's a 25,000-foot ash plume as Sabancaya explodes. Please do not pole vault the caldera. Next, looking at seismic activity for the past 24 hours. And it's been a lot calmer than the past couple of days. No major quakes. Let's check out the list here from USGS. We will cite quakes over a 5 magnitude. We'll ignore that 4.7 in Chile. It's probably a knockoff earthquake built with stolen U.S. intellectual capital from the United States of America. Okay. There's also a 5.4 at New Zealand. That was at 22:16 yesterday evening, 22:16 Universal Time, that is. There was also a 5.2, which is an aftershock. Keep in mind, any earthquake can be a foreshock, so there could be a larger quake about to happen there at New Zealand, although it looks like things are calming down. There's also a 5.7 at the mid-Indian Ridge there, kind of right in the middle of the Indian Ocean. Not the most common place for a quake there, although there is a plate boundary. We also had a 5.0 in Papua New Guinea. That was at 1:18 this morning on the 26th of April. And since then, no quakes over a 5 magnitude. Some small quakes around the west coast of the U.S. also there. Again, quick reminder, any earthquake can be a foreshock. And welcome back to space. This is another 24-hour video here featuring SDO 171 plus 211 angstroms. And let's switch to plain old 171 angstroms. There you go. There is the house favorite wavelength. And many of our viewers are delighted by the 171 angstroms wavelength. I found it amazing when I realized that I could access this data all the time. I knew it would be a deep dive into heliophysics. I didn't realize how deep the rabbit hole was. And let's talk solar stats here. The 10.7 centimeter radial flux now all the way down to 131 solar flux units. Another decline in the radial flux. There is the 1-year graph to put it in context. It's the black line. At the top of that graph, again, 131. 131 is the number of solar flux units, which, by the way, those are 10,000 Jansky, which is just a measurement of radiation traveling through outer space. The red line is a sunspot number. Perhaps you can see how proportional those are. Sunspot number and radio flux are directly proportional data sets. Now, NOAA's being a little bit wishy-washy here. They are forecasting a minor geomagnetic storm early in the day on Friday. It's from, quote, coronal hole, high-speed stream, and coronal mass ejection effects. So they are expecting a glancing blow here. And besides that, things are expected to be mostly calm. So let's briefly show you their Enlil spiral. This is the NOAA Enlil spiral. And not a particularly definitive forecast there. We stated that we expected this CME at least to miss off to the south. So it looks like NASA's forecast once again is a little bit better than NOAA's here. But that's the data from the Space Weather Prediction Center's Space Weather Enthusiast dashboard. Here is the information from NASA's Enlil spiral. And what you're looking at here is over here on the left. This is like a top view, as if you're viewing the sun from its north pole. And on the right, in the middle actually, that's as if you've turned that edge-on view on its side. And you can see, like we said yesterday, this CME is likely to mostly miss Earth. It could have a small glancing blow type component, but most of the CME will be off to the south, as you can see here on the imagery. So again, if it is a strike, it'll be a very minor strike. It could even be covered up by a coronal hole high-speed stream. Let's take a look at some more data here. Here's the past 4 hours of Earth's magnetic moment from space. Things are geomagnetically calm at the moment. This 4-hour movie depicts magnetohydrodynamic pressure, the units of which are nanopascals. And keep in mind, we do have a significantly elevated solar wind stream from a coronal hole high-speed stream. So coronal holes are like low-pressure systems on the sun, and the thing to understand about low-pressure systems on stars is that they are so low that they blast material into their stellar systems. Think of a sunspot as a high-pressure zone and a coronal hole as a low-pressure zone. Next, ground magnetic perturbations. Here's Earth's magnetic moment from the ground. The units here depicted are nanotesla magnetic flux density. And like our geospace magnetosphere movie, our ground magnetic perturbations map is also the past 4 hours. If you're worried about Earth's poles suddenly shifting and things like that, well, you could follow this all day. It will auto-refresh for you, and you can be assured that it's very unlikely for a magnetic reversal to occur on Earth. And to all the YouTube channels out there that are suggesting that we're going to have a magnetic reversal, for shame. For shame. Talk about pathetic. How about looking at all the data, not just the scariest, spookiest data, and filling the heads of your uninformed viewers with utter nonsense? KP index is currently at 2. That is an average of global geomagnetism. KP2 is the geomagnetically calm condition. Let's take a look at the real-time solar wind next, measured outside Earth's magnetosphere out here at Lagrange 1 by typically the ACE and Discover. At the moment, the Discover's online, showing us that the solar wind speed remains elevated here at over 500 kilometers per second. Solar wind density here at about just under 9 protons per cubic centimeter. Now, wait a minute. About 10 protons per cubic centimeter. Besides that, pretty unremarkable here. It's just a fairly weak coronal hole high-speed stream. And the density wave, I believe, was mixed in with our KP8 coronal mass ejection impact. So there was a little bit of a oddity happening there. We never really saw the density spike. This does happen as solar plasma interacts with itself as it passes through the space between the Earth and Sun. Next goes magnetometers here, showing a decent spike here. That was associated with a plasma temperature increase, so right around here, around 2000. Yesterday we did see a little variation in the plasma temperature and a minor change in the magnetic fields. Plasma temperature went down and then came back up, and that likely caused this magnetometer spike. Those GOES magnetometers are located at geosynchronous near equatorial orbits. They're at about 23,500 miles of altitude. They are way up there, like twice the altitude of your GPS satellite. Next, we'll look at the heliospheric current sheet. The solar plasma is polar, and Earth is in a south pole current sheet, kind of right in the middle of it, and we may see an extended stay here of the south pole current sheet. So this is a prime example of where we explain how to read this data. So let's break this down for a minute. If you look at the latest image here, you may see in like tomorrow's video, for example, you may see that this portion of the current sheet right here looks like it's kind of moving this way, the south pole current sheet. And that is typically a thing that we would see as a result of that large sunspot that just rose in the northeast. So that can sort of pull the solar B field up toward the north, and that would allow the south pole current sheet for an extended stay. So we'll see what happens here. If we do see a similar sunspot rise in the southeast, then that would sort of equalize things. But at the moment, it looks like we may see the south pole current sheet staying a little bit longer than initially expected. Let's take a look at some more national Solar Observatory magnetic data. Here's your line of sight plot featuring the gong magnetogram as well as the solar B field in blue. Solar polar fields in red for south and green for north, which brings us to coronal holes. And by the way, we think we've explained the mechanism that underlies the solar sunspot cycles. It's very weird and creepy, and frankly, our theory is CRAPF. Yeah, CRAPF. CRAPF. And we won't be telling you what that means, although our Gold Smash team members are already aware. So we've got a bunch of South Pole-oriented coronal holes, and that is a large number of coronal holes there. So all of the coronal holes on the Earth-facing portion of the solar disk are South Pole-oriented. That makes our life easy when we evaluate the 211 angstroms wavelength. Welcome to the South Pole, the South Solar Magnetic Pole, that is. And that brings us to sunspots. So, once again, we do have a propensity for solar flares coming from this area setting down here. It looks like we have a new sunspot here also, but this sunspot up here will get a name also, so that'll be 3290. That is a significant sunspot. Most likely places for large flares would be at 3289 and at 3290. The likelihood of large flares at 3289 goes down as it moves toward the Earth, and the likelihood of large flares at 3284 goes up as it moves toward the limb. Those are just statistical facts about the likelihood of solar flares. They're more likely at the edge of the solar disk than in the Earth-facing portion. At the center, in other words, you're a lot less likely to see a large flare in this part of the solar disk than you are in the rest. Those are facts. I'm sticking to them. Here come some more SDO videos. There's continuum plus 94 angstroms to highlight the active regions as well as show the umbra of the sunspots. Those dark regions, and by the way, there is a valid explanation in the real world of physics as to why sunspots are dark. If you ask Robitaille, well, he might tell you what I told him. Sunspots are dark because they're flat. Yeah, they're flat. And metals do not like to emit photons perpendicular to their flattened surface. They emit photons at an acute angle to their surface. It's a valid explanation in physics as to why sunspots are dark, because you're seeing almost pure condensed matter down there. Sunspots, they're dark because they're flat. And check out the rapid formation of 3290 up there in the upper right. A great example of how the magnetic environment can change with basically no warning. Also, we may have a new named group right here, and also a likely named group up here, and a new named group up here. So lots of new sunspots here showing up in the past 24 hours. All of that will increase the radio flux and the likelihood of solar flares. Let's take a look at energetic particles next, as we are wont to do on the channel. No solar energetic particle events, or SEPs, have occurred since actually during the most significant geomagnetic storm in over 20 years. The X-ray flux, again, you can expect this to rise here. At the moment here, we're in a B-class background X-ray flux. Expect this to move back into the C-class X-ray flux throughout the day today. Here are some great wavelengths to view solar flares. That's 131 plus 94 angstroms. Those wavelengths are specifically formulated to view solar flares. That's why you often see these wavelengths appearing on people's thumbnails on their space weather videos. Here's a great close-up of the equatorial region. And let's switch to an extreme close-up of the northeastern limb here, as we've got another quite large and quite magnetically complex sunspot having just risen. Next, we'll take a step back from staring at the sun. Once again, thanks for joining our channel to stare at the sun. Here's what's going on overhead Lehigh Valley, Pennsylvania. Jupiter is in Pisces, which means something to somebody. I don't know what. It means that Zeus... When Jupiter is in Pisces, does that mean that Zeus has gone fishing? Wait, Jupiter... Yeah, Jupiter is Zeus, right? Saturn is Poseidon. So, since it's in Pisces, does that mean Zeus has gone fishing? Let us know in the comments what you think. Anyway, that's our star chart. You've got the sun chasing Jupiter there, and Jupiter chasing Saturn across the ecliptic. And you've got Venus just rising here, just coming over the horizon. There it is. By the way, that star chart is from skyandtelescope.org. I like it, so I use it. Next, the solar system forecast. And here's where things are now. It's terrestrial planets versus gas giants. Check it out. There's a line in the solar system. We've got terrestrial planets on one side, all 4 of them, and gas giants on the other side, all 4 of them. It's gas giants versus rocky planets. Who will win? The answer is nobody. They barely affect each other. Here's your 1-week solar system forecast. Here's where things will be on May 3rd. And let's move to coronagraphs, since there have been some coronal mass ejections. But first, take a moment to visit the links below the video. So we've been making merch for quite a while now, and it's for various different reasons. This one is like a public service message. Make Earth not suck again, as there are plenty of YouTube channels, plenty of big tech organizations, plenty of pharmaceutical companies, plenty of bureaucrats who are making Earth suck. You may have noticed since March of 2020 that the planet has sucked. Why? Because of ignorance, arrogance, greed, and a lust for power. So make Earth not suck again. It's up to you. I've got a Mensa hat. Do you? This product is popular enough that it made it all the way to Tasmania. And for you international viewers, yes, the merch products do indeed ship internationally. So make Earth not suck again. It's up to you, not giant bureaucracies that can't even get out of their way or effectively do their own jobs. So here are some coronagraphs. This is all day yesterday. That's 102 frames. Little CME out of the northeast there. Little CME out of the south. We'll also show today's available frames. And again, there are actually 2 coronal mass ejections propagating as we speak. This is a great example of one right here. Let me bring up the last image there. So this is a great example of what we see with coronal mass ejections. Some people may have been very confused about this, but this is a great example of how you've got a shell, and then you've got a core, which might have completely different properties, and then another shell. So sometimes when a CME like that strikes Earth, what you'll see is the remnants of this shell. Of course, it's getting more diffuse as it goes through space, but what's really cool is that you'll see this initial impact, and then you'll see like a lull in the storm, almost like an eye of the hurricane. And this will often have different properties because it's like this, it's almost as if this is like a shell that is suspending this. And again, it can have different properties, and that's exactly what we saw in this most recent coronal mass ejection. We saw first this initial portion, and then the core of the KP8 coronal mass ejection impact that we saw a couple of days ago. That was quite neutral. It was sort of like an inert core, like a hollow core. And then as that moved off, we saw another impact from the trailing edge. The leading and trailing edge both had really strong magnetic fields, and the core had a weak magnetic field. So that's a great example there. And of course, CMEs have various different structures. Sometimes they are just like a single cloud. Sometimes they come out in all kinds of different filamentary shapes and so on. And so you have to sort of guess what's going on there by understanding the physics in the space weather data, like the solar wind data. Let's take a look at stereo A here, again, since we had some CMEs propagating as we did show prep today. We don't expect them to be earthly directed, by the way. So here are 90 frames from stereo A on the left and Soho Lasco C3 on the right. You can also see Mercury there on the stereo A. And there's a great CME happening. Fantastic. And here are some 24-hour videos. So those CMEs do not appear to be earthly directed. You would typically see some plasma motions happening. And of course, down here you do see one. That's not earthly directed either. That's off to the southwest. This one over here is coming from behind the northeastern limb. So you're not really going to see any plasma motions up there. 193 angstroms is a great wavelength to observe those plasma motions. And let's take a look at filaments, because it is certainly another major day for solar filaments. In fact, we're going to name one right here on the video. So this filament up here, ahead of sunspot 3289, and a bit to its north, is very, very dense. And so this one's getting a name. So let's just briefly show you the process. Now, we would prefer if you would actually tell us which filament you'd like named, but just follow the hashtag #NameThatFilament, and I'll just take a snippet of that. And then I'll head to Twitter. So if you're not on Twitter, get an account. If you've unplugged from social media, we don't blame you, because it is truly pathetic. And unfortunately, it did not screenshot my arrow there. So anyway, this filament up here is the one that we're talking about. I'll edit that later. And we're going to name this filament, how about Oh, Richard Dean Anderson has no Twitter? All right. How about, let's see, who can we name a filament after? How about if we name it after, we'll name it after the winner of the, which race was that? Anyway, we'll name it after Remco Evenepoel. How about that? It's the Remco Evenepoel filament, the current world champion of the UCI, the Union Cycliste Internationale. Again, follow us over on Twitter if you want to name filaments. It's hashtag #NameThatFilament. Pretty basic. And again, massive number of coronal holes here, an increase in the sunspot number coming today, along with the radio flux and the X-ray output. So that's what's going on. 193 angstroms is a great wavelength to view various features from active regions, the extended corona, coronal holes, and solar filaments. This is another 24-hour video, by the way. And here is the past couple of hours from the GOES 16 SUVI. You can see those CMEs propagating from the northwest. There's a little CME happening up there. It's starting out as a prominence, and then much of that material blasting off into space, which brings us to our bonus features segment. And thanks for blasting off to space with us. A channel chock full of objective facts. So we do have some minor surface charging hazards here. Those are of the surface charging variety. Those are charging hazards caused by electrons building up on the outsides of spacecraft. They can cause some minor communication errors. Not expecting anything major here from that. Let's move on to our GOES electron flux here, which came up off the floor as we forecasted. There is the past 3 days of radiographic measurements there by the GOES 16 and GOES 18. And there is the forecast model. NOAA was expecting a big increase, but we got a moderate increase, just a minor increase instead. And NOAA's expecting it to level off. No arguments from me this time on the forecast. There's the 1-year graph to put it in context. We just came out of the longest electron trough of the past year. Some very low levels of electron flux there as we saw extended coronal hole high-speed streams and a major CME impact. That electron flux is measured at the F layer of the ionosphere. Let's take a look at the vibrations going on in the F layer at about 300 kilometers of altitude. And we're seeing low-frequency anomalies continuing here. So these began when the solar plasma from that massive, perfectly Earth-directed coronal mass ejection impact occurred. And they still have not subsided. So lots of low-frequency anomalies. The ionosphere is puffed up, basically. This is an indication that we're getting denser material at this altitude. Again, 300 kilometers is approximately where the F layer is located. And in many ways, it is the bridge between Earth and space. If you're not familiar with that imagery, don't worry. Here's the anomalogram, which shows anomaly in megahertz from a 30-day median. It is slowly subsiding here. However, Earth's ionosphere is still heavily puffed up. So you're getting likely high density there. High density is going to cause lower vibration. Lots of low-frequency anomalies on a planet-wide scale. So it's a great time for guys like Scott McIntosh who do things like study magnetohydrodynamic waves. I suspect he's been kind of busy here. I'm going to drop him an email. We are still trying to get Scott McIntosh on the channel. Shout out to Scott for his propensity to not believe nonsense or support ridiculous, pathetic theories in the realm of heliophysics. Anyway, here's your latest images. That's 12 noon Universal Time ionogram and 12 noon Universal Time anomalygram. Continuing on to our total electron content forecast, it's the free electrons up to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're unfamiliar with the distances to things like the Outer Van Allen belt in miles. Here is the free electrons up to about 12,500 miles of altitude, which is about the distance of the run from your GPS handset to your satellite. Those free electrons can cause signal refraction. At the moment, things are fairly organized here regarding electron contents. So nothing too funky going on there. And let's close out the space weather portion of the video with the latest intensitygram and latest SDO magnetogram. So there you have it. First, we'll take a look at 3289. And it is indeed magnetically complex. You've got, looks like a couple of North Pole leading umbrae there. And then a South Pole umbra down there, it looks like. Yeah. So it is beta gamma class. Hard to say if it's beta gamma delta class, but it could be. And in my opinion, it's the most likely place to see a large flare. The second most likely place would be here, followed by up here, and then finally this series of sunspot groups. Keep in mind there's a lot of plasma on the Earth-facing portion of the solar disk. All those filaments that we've shown, those are involved with coronal mass ejections and solar flares. Many of us are seeing more and more evidence to indicate that plasma filaments moving around is what causes the flares. In other words, solar flares don't cause coronal mass ejections. We think coronal mass ejections cause solar flares. Anyway, there's the rock back, and we've got a couple new sunspot groups, at least 2 new sunspot groups likely to be named up here. This one here, 3290, and 3291 over here, and there may even be more. So it's a significant uptick since yesterday, and let's move to our meteorology segment. So the first thing we're looking at is earthly temperatures. So let's take a look at the extremes briefly as we kick off our meteorology segment. Shifting gears to croissant Earth, projected onto a fake spherical NASA template to fool people into thinking that the planet is shaped like an oblate spheroid instead of the French breakfast pastry known as a croissant. Pardon the sarcasm. We're just trying to make everybody on the internet angry. So, here's the current situation here. We've got the hottest temperatures in the world, I believe, are in Central Africa. They're at over 110 degrees. Figured we'd start off with that. That looks hotter than India and Southeast Asia. So those are the hottest portions of the planet. And as winter gets closer, the coldest portion of the planet is down here at negative 73. I think we can go even higher than that. Negative 75 there. On the highest and driest continent. Yeah, Antarctica. It's the driest desert in the world. Were you aware of this? Yeah, Antarctica. It's the highest and driest continent. It's got not only the least humidity, but it's also got the highest average altitude. Let's move on to our regularly scheduled meteorology. Here are the surface winds of the eastern world, like sands through the hourglass of time. These are the surface winds of your lives. And these are the jet streams. Here's the western world. We've got like a quadruple jet stream there over the eastern portion of North America. Here are the surface winds of the west, surface winds of the central world, and there you have the jet streams. Let's blast through the rest of our meteorology segment here. We don't want the video to be too lengthy. So here is clouds and fog, depicted by the NASA GOES interactive weather satellite, gathering the photons at a 3.9 micrometer wavelength. It's part of the infrared spectrum, and it allows you to see clouds and fog when it's too dark to use a visible satellite. Next, our weather.gov map. We've got some continued cold temperatures in the east, some freeze advisories, and so on. If your location is lit, click your location. We've briefly scrolled down to show you the key. Weather.gov is the National Weather Service website, weather.gov. And here come some forecasts. But first, let's talk about snow. And why? Because we've got hydrologic output up here, and hydrologic outlooks, rather. And there are some major snow melts that will continue. So looking at Global Cryosphere Watch here to check out the snow extent, mass balance, and water equivalent. Let's start out with the mass balance. And the mass balance here is at the high side of the range. That blue shaded region is the plus or minus 1 standard deviation for 1982 through 2012. A little bit on the high side there. Keep in mind that does not include mountains. So places like California, which still have feet and feet and feet of snowpack, are not included in that data. That is the snow mass balance. In other words, the snow in a 3D interpolation of the data. Next, snow extent. Now coming back out of the plus or minus 1 standard deviation range, which is the area between those blue lines. So snow extent here above average as we push toward the end of April. Last but not least, the snow water equivalent, and this is the major one. This is going to continue to cause flooding. Look at the snow water equivalent. It's berserk. It's way off the scale there, well outside the plus or minus 1 standard deviation from 1998 to 2011. It's the 7th consecutive year of record snow in the Northern Hemisphere, and here come some forecasts. So all that warm weather in places like California is going to cause shocking amounts of flooding. If you're downstream from huge amounts of record snowpack, be prepared, as you don't necessarily need to see rain to see shocking flooding. That's a temperature anomaly forecast for the next 72 hours based on a GFS model in degrees Celsius. We'll also show pressure and precipitation for the same model, the GFS 72 hour. Some very, very strong storms there coming to Texas. East Texas, you're going to see two very strong systems. One forming in about a day and the other in about 3 days. Some major weather coming back to the Gulf Coast region, as if you haven't been pummeled enough times down there. Here comes some more possibility of things like tornadoes, damaging wind and hail. What the hail? That is two major systems about to form, as you can see. Next, we'll go to windy.com and look at this is our moisture anomaly, soil moisture anomaly. So the center of the country here is quite dry, also the mid-Atlantic. Meanwhile, Texas, parts of Colorado and Kansas are quite wet. Also, southern Florida here, anomalously wet. In South Dakota, they're having both drought features and anomalously moist soil features. One of the many features there of Witty.com, the check globe data showing soil moisture anomaly. Pretty sweet. Next, we've got lightning. And Texas and Oklahoma were the lightning capitals of the past about 10 hours. Some pretty serious lightning there. And let's see if we have any terrestrial strikes. And what we've done here, by the way, this is lightningmaps.org. You may not have seen this view before. And the reason you're seeing that, lightningmaps.org, by the way, is the real-time lightning map that we show daily on the channel. And what that is, what those shaded regions are, those are the coverage regions. So I just turned those on just to show you that the whole planet is not covered here. This is not satellite data. This is ground-based lightning detection. And you can see the coverage area. For example, Australia doesn't really have coverage area there. So anyway, just wanted to show you that this is not a complete picture. This is limited by the coverage area. So anyway, let me turn that back off again. There we go. It looks like we do have some lightning happening in the U.S. here. West of Wichita Falls, there are some active cells there. Right at Wichita Falls. Hey, Wichita Falls, there's thunder rolling in. And also some near Dallas. And we'll close out this video with some U.S. Doppler radar. There's the full 50 state view. And there's the lower 48 view. We've got clouds and fog also. And oh, that is a great error message. All right, thank you very much. Can't open user profile directory because you lack sufficient privileges. You might want to add contact administrator of this machine. Oh, okay. Yeah, I'll get right on that, Opera GX. Great idea. All right. Yeah. I don't know what it is. The past week or so, we've been having some technical difficulties trying to show you the freaking U.S. cloud cover and U.S. water vapor map. I don't know what's up with it. It has been a real pain in the you know what. It's been a pain in the junk. But don't worry, we've got it. I'm bringing it up right now. Just give me a minute here. In the meantime, take a moment to press like, subscribe, share, etc. Tell your friends and foes about the content. And leave us a comment expressing how mad you are that we failed to show you the U.S. cloud cover and U.S. water vapor map. Leave a derogatory comment if it floats your boat. Anyway, there's clouds and fog over the U.S. And there is the water vapor map. You can see an impulse there of dry, massive air interacting with all that moisture. We've also got some cold air pushing in from the north up here. So you can see that cold air pushing down. That's going to create another impulse here because we've got this colder air is more massive and this drier air is also more massive. So that's going to help to create massive pressure gradients there and precipitation. It's going to kind of linger. It doesn't look like it's moving very fast. The water vapor map can really help you out if your Doppler is not clear. So use the NASA Interactive Weather Satellite Suite for that. There's the recap U.S. Doppler radar, clouds and fog, and water vapor. And that is where we will close things out at the Smash News Network Least Busted Name and News. By the way, these videos were brought to you in part by our affiliates/sponsors and by the Smash team. So consider joining the Smash team if you prefer to see these videos continue to remain existent, publicly visible, and free for all to view. Smashomash.com/Smash team is our own custom subscription services site. We replaced Patreon with a superior site of our own making because, well, we needed superior capabilities. So that's why we built the site. Smashomash.com/Smash team launched in October of 2021. Thanks most of all to our gold and silver Smash team members. We send out email alerts even to our bronze level Smash team, by the way. That'll cost you $0 a month. Silver is $2.99 a month. Gold is $9.99 a month. One of our affiliate sponsors is Hemp Lucid. So you can find a link below the video to the Hemp Lucid shop, and don't forget to enter the promo code SMASHOMASH to save some dough on checkout. Today's featured product is the Focus Mushroom Gummies in grape. So I actually use these myself. They've got lion's mane. They are not going to cause any drug-like effects. They are for focus. They will give you a calm sense of focus, basically. Or perhaps they will, and let us know if you've tried them out. There's a little description of what they are and so on. Just click the link below the video, or you can find the Hemp Lucid link on the homepage at smashomash.com. Thanks to everybody who's picked up products from our affiliate/sponsor Hemp Lucid. Again, don't forget to enter the promo code SMASHOMASH to save some dough on your checkout. The Focus Mushroom Gummies, I officially endorse those. And as a pro bike racer, you can take my endorsements seriously, or you can completely discard them. It's not going to insult me either way. If you don't believe me, that's fine. Good luck. Also, if you're unwilling or unable to open your cobweb-encrusted wallet and help the channel out with a Smash Team membership, or perhaps picking up some merch for the Redbubble shop, or perhaps some Hemp Lucid products, help us out with clicks. Join us on our Discord chat. There's a permanent invite link over there as well. We'll see you soon at the Smash News Network Least Busted Name and News. Thanks again to the Smash team. Congratulations to the rest of you on realizing the channel exists. In the meantime, I'll have been your host, Dan, a.k.a. Smashomash, signing off, and may that solar wind be at your back.